Next, we're going to look at an EBA option for freshwater ecosystems focusing on watershed and reservoir. A watershed is the geographical area drained by a watercourse. The concept applies at various scales from, for example, a farm drained by a creek to a large river basin or a lake basin. Forests and trees play crucial roles in hydrological processes and watersheds, particularly on sloping lands. The concept of watershed management is developed based on the relationship between upstream land use and water yields and quality downstream. In the Pacific, typical watershed consists of three zones: upper zone, on mountain and hilltops where natural forests and deeply cut tributaries are there; middle zone, where river floodplains where the vast majority of development is occurring; lower zone, mangrove forest at sea level, making it a nursery for many marine creatures. The functions and services of watershed are diverse, including attenuate terrestrial runoff to the marine environment, provide fresh water, particularly upland watersheds, regulate water flow and maintain water quality, provide and protect natural resources for local livelihoods, protect against natural hazards such as local floods and landslides, and conserve biodiversity. Now, how are watershed and reservoir ecosystems impacted by climate change? These ecosystems are primarily impacted by changing precipitation regimes. Decreasing precipitation regimes will lead to ecosystem transformation, biodiversity loss, contraction of watershed area, and loss of freshwater lands. Increasing precipitation will have largely positive impacts in freshwater ecosystems where they maintain intrinsic integrity. Watershed ecosystems are also impacted by non-climate threats such as deforestation, uncontrolled timber harvesting, overgrazing, pollution, and the invasion of alien species. Consequent changes resulted from deteriorated watershed function include erosion and the depletion of soil productivity, sedimentation of water courses, reservoirs, and coasts, increased runoff and flash flooding, reduced infiltration to groundwater, reduced water quality, and loss of aquatic habitat and biodiversity. Typical EBA options in the watershed and reservoir interface are protection of natural forest, restoration of plant cover in the watershed, planting native vegetation as riparian buffers. These options aim to address flooding and soil erosion or sediment deposition resulting from extreme rainfall variability, and increasingly frequent and severe cyclones. We have already looked at why the protection of natural forest is important and how it is designed and managed earlier in the forest session, so we skip its explanation and get down to the second option, restoration of plant cover in the watershed directly. Riparian buffers refers to strips of vegetation along the banks of waterways such as lakes, rivers, and streams that maintain or improve water quality by trapping and removing various non-point source pollutants from both overland and shallow subsurface flow. In general, riparian buffer design consists of a strip of grass, shrubs, and trees between the normal bankful water level and cropland. To maximize benefits and co-benefits, it is desirable to plant native, climate-resilient, and multi-use species that benefit local communities, for example by providing non-timber forest products such as nut and fruit, riparian buffer is also considered as an option of ecosystem-based disaster risk reduction, or eco-DRR, for its function to buffer floodwater, slow the flow, and absorb excess water. Now, let's look at the benefits and co-benefits of riparian buffers in addressing climate change. As adaptation benefits, riparian buffers reduce vulnerability to floods by acting as a shield against overland flow from agricultural fields by reducing the runoff of sediments and pollutants reaching the watercourse. Maintain or improve water quality by trapping and removing various non-point source pollutants from both overland and shallow subsurface flow. Provide direct shade for the water body, reducing the influx of solar radiation on it and thus avoiding the corresponding increase in water temperature, and provide additional habitat for aquatic species. As mitigation benefit, riparian buffer promotes carbon sequestration by planting trees. Examples of outcome indicators of riparian buffers include frequency and severity of floods, sediment load, measures of water quality, measures of flood damage such as infrastructure, households, crops, and agricultural yields and income, if any. Then, what are the success and limiting factors for riparian buffers? First, success of buffer strips is strongly dependent on characteristics such as buffer zone width, slope of the adjacent fields, soil type and variety, and density of vegetation. It should be also noted that temporary negative side effects may happen during the plantation of vegetation and related works along the water body, but medium to long-term effects are in general positive if the option is carefully designed and planned. There are a variety of social and economic factors that can curb the adoption of riparian buffers that include lack of incentive program, poorly defined goals, lack of maintenance, and opposition from landowners. This is an example of a project that contains the establishment of riparian buffers in the Pacific Island. The project name is Restoration and Reforestation of the Riparian Zone of the Lower Tegabi River in Port Vila, Vanuatu. In fact, this project is also one of the EBA demonstration projects of PBAC. In this project, approximately 3,000 native trees, fruit trees, and vetiver grass were planted along the Black Sands coastline and from the river mouth up to the destination area. These plants help reduce erosion and eventually provide shade along the river, reducing sunlight, which curbs the growth of invasive aquatic plants.